This video will discuss statistics in Excel. That includes topics such as population and samples, arithmetic mean, and standard deviation and variance. First, we need to understand the difference between a population and a sample. So, what's the difference? Let's use an example to help explain. A professor has 36 students enrolled in a class. The class forms a population. If the professor tracks the grades for each student after an exam, the data represents the grades for the population. If the professor falls behind in grading and only grades 10 exams before class, he may decide to use those 10 exams to estimate the class average on this exam. Those 10 graded exams would be called a data set that represents a sample of the total population. We will begin our discussion about statistics in Excel with the arithmetic mean, also known as the average. As you can see, there are two types of means: the population mean, mu, and the sample mean, x bar. The population mean is equal to the summation of all the values in the dataset divided by the number of values in the dataset. The sample mean is equal to the summation of the values in the sample dataset divided by the number of values in the sample dataset. You can see that both these equations add up all the values in their dataset and divide by the number of values in their dataset. However, an important distinction needs to be made. The population mean is the average for the dataset, while the sample mean can be thought of as the best estimate of the population mean. Excel already has an average function built in that is very user-friendly. Let's see how it works. So here is a worksheet with all 36 exam grades on the left and a random sample of 10 of the exam grades on the right. This will be used to demonstrate the average function that is already built into Excel and how the mean will vary slightly whether you use the population or the sample dataset. Let's begin with the population mean. Go down and select the mean cell. Begin typing equals followed by average. Once you have selected the average function, click and drag to highlight the 36 exam grades. End the parentheses and press enter. The population mean is equal to 75.75. Now do the same calculation for the sample dataset. In the mean cell, type equals followed by average. Click and drag to select the 10 grades in the sample dataset. End the parentheses and press enter. The sample mean is equal to 77.30. Once both means have been calculated, it is clear that the population mean is the average and the sample mean is an estimation of the average. It is important to note that when using instruments such as thermometers and scales, it is common practice to take several readings to get a more accurate result. When taking multiple readings, you are taking a sample because the population is an infinite number of possible readings. It will become clear why we treat readings as samples when the equations for standard deviation and variance are shown. Now we will move on to standard deviation and variance. Standard deviation and variance give information about the dispersion of values about the mean. A small standard deviation and variance conveys that the data values are close to the value of the mean or clustered around the mean. Similarly, a large standard deviation and variance convey that the data covers a wide range of values. These values are utilized when graphing a normal distribution or bell curve. Here is a normal distribution curve. You can see the maximum is when x is equal to the mean. It is symmetric about the mean, and the inflection points are at plus and minus the standard deviation. The curve asymptotically approaches the x-axis, and the area under the curve is equal to 1. Shown here is the equation for a normal distribution curve. To clarify this concept, let's see an example. Here I have set up an Excel spreadsheet with grades from 2 different classes that intentionally have the same mean. We can use this to demonstrate that although 2 sets of data have the same mean, the standard deviation and variance can be quite different. To begin, I'm going to use Excel's built-in functions to calculate standard deviation and variance for the 2 classes. Go up and select the standard deviation cell. Begin typing equals followed by standard deviation. You can see the function pops up right away. I'm going to treat this as a sample, so select the standard deviation function that is followed by an S. Go over, click, and drag to select all the values in the dataset for Class 1. End your parentheses and press Enter. Your standard deviation for Class 1 is 14.6. Calculating the variance is very similar. Select the variance cell and begin typing variance. Again, the function pops up, and we are going to treat this dataset as a sample also. So select the variance function followed by an S. As before, click and drag to select the data for Class 1. Close the parentheses and press Enter. The variance for Class 1 is 213. Use the same functions to calculate the standard deviation and variance for Class 2. Click in the standard deviation cell. Start typing standard deviation. We are going to treat this as a sample again. Go over and select the data for Class 2. End the parentheses and press Enter. The standard deviation for Class 2 is 6.59. And finally, the variance again. Type in equals, variance, choose the sample variance, highlight the data for Class 2, end the parentheses, and press Enter. The variance for Class 2 is 43.4. Now that the calculations are complete, let's analyze the results. Remember, these sets of data both have the same average, but the standard deviation and variance will tell us more about the dispersion. Class 1 has a standard deviation of 14.6 and a variance of 213. If you were to create a normal distribution curve, you would have the mean equal to 79.1 and the inflection points at positive 14.6 and negative 14.6. Also notice that the standard deviation is the square root of variance. Looking at the data for Class 2, it has a standard deviation of 6.59 and a variance of 43.4. Because the variance for Class 2 is smaller than the variance for Class 1, the normal distribution curve will be more narrow. As seen here, the mean will stay the same at 79.1. The inflection points will now be at positive 6.59 and negative 6.59. Again, notice that the standard deviation is the square root of variance. The two curves show that the range of scores for Class 1 is wider than the range of scores for Class 2. A scatter plot can also be used to show distribution about a mean. Let's take a look. Here I have simply created a scatter plot with Class 1 as a series and Class 2 as a series. Let's have a closer look. By looking at Class 1's data, the blue diamond series, it is clear that the values cover a wide range and are not necessarily close to the average. Looking at Class 2's data, the red square series, you can see that the data covers a smaller range and the difference between the values and the average are not as large. Now that you know what standard deviation and variance are, let's see how the equations differ between populations and samples. I will start with population statistics. The Greek symbol sigma squared is used in population statistics for variance. This equation states that the variance for a population is equal to the summation of each data value minus the population mean squared divided by the number of data values. The notation for standard deviation is simply sigma and is equal to the square root of the variance. Let's now see how the statistics for a sample are different. The letter S squared is used to denote the variance of a sample. The variance of a sample is equal to the summation of each data value minus the sample mean squared divided by the number of data values minus 1. The standard deviation of a sample is denoted by the letter S and is equal to the square root of the variance. So, how important is it to know if the data is a population or a sample? Let's find out. Here, I just made an Excel worksheet with random numbers to demonstrate how the standard deviation and variance change whether we use population statistics or sample statistics. I am just going to quickly type in the equations as I did earlier. When you enter the standard deviation function, make sure you choose the correct one. In this case, we want population. Do the same thing with variance, and again, ensure that you are using the population variance here. Now go over and enter the functions for the sample statistics. This time, make sure you choose the sample standard deviation function. Also make sure you choose the sample variance. You can see that Excel gives 5 decimal places, but I'm going to format that to 1 because that's all the accuracy that is needed here. Now we can analyze our results. We can see that the standard deviations are different by about 1, and the variance differ by much more than that. A smaller standard deviation translates into a more narrow normal distribution curve, while a larger standard deviation translates into a wider normal distribution curve. With such different variances, it is clear why it is important to know if you are using sample or population statistics.